statistics. What I want to do right now is just look at some terms, definitions, and so on as an introduction to the area of statistics. So let's do that. All right, I got this list of terms prepared before, so let's look at them. Statistics, what is that? Let me increase the view so you can see it a little more close up. One definition of statistics is that it is a branch of mathematics that involves the collection, analysis, interpretation, and presentation of numerical data. All right. Now, it says here numerical data. The data, original data, may not necessarily be numerical, as we will see later. But we then can assign numbers to those data. All right. Now, let's look at the steps involved in statistical investigation. Step number 1, identifying the problem. It's some type of problem that you want to solve, right? You identify the problem and you formulate questions or assumptions that can be answered with the data. Now, the data is just a piece of information. Now, in this case, the assumption could be that persons believe, or you assume that the apple is the favorite fruits of these students. There's an argument as to whether apple or oranges are the favorite fruits, and you make an assumption. Apple are the favorite fruits. The other side says oranges are the favorite fruits. So you pick a side and say, I'm going to assume that apple are the favorite fruits, and you carry out an experiment to show that. All right. Now, that will be the case when you're doing a type of study where you want to analyze to form a two-sided study. All right. We'll look at that later on, where you analyze the data to form a test, two-sided test, I should say, to see if one set of assumption is correct or it is not correct. Right? That's for later on. But for now, what we'll be looking at are questions instead of assumption. Assumption will come in using the normal curve and the what they call it two-tailed test or the one-tailed test and so on and so forth. We leave the assumption till later, but for now, we're going to be concentrating on formulating questions that can be answered with the data. Now, that's step 1. You identify the problem and you come up with questions. Step 2, you design a method that can collect the data. So, it might be a case where the method is used to collect data. For example, it may be some questions, and we're going to look at the different types of questions. It could be on printed paper or on a computer or phone screen that you send online, whatever method it is. That's step 2. So you identify the problem and you formulate questions. That's step 1. Step 2, you put together a method that you can use to collect the data, the answers from persons. Step 3, you collect and analyze the data. So you look at all those answers and you put them together, analyze them, and then step 4, you interpret what they mean. Were you right when you made your assumption? But what do they mean? Do these answers mean that this particular political party is in a better position to win the next election? Does it mean that the business that you're going to set up, the auto parts place that you're going to set up, should invest more in Toyota parts than Honda or Nissan parts? You interpret the data, right? Now, so those are the steps in your statistical investigation. You identify the problem and form questions. So you come up with the questions. That's 1. 2, you come up with a method that you can use to collect the data from persons. 3, you collect and analyze the data. And then 4, you put your interpretation. What does this all mean? All right? So those are the 4 main steps in putting together your investigation. Now, the methods you use to collect the data. 1, it could be observation. You yourself go out there and you look, you count, you put down the data, the information that you observe. All right? It could be interview, whether it's face-to-face interview or over telephone or online. That's another method. You interview the persons. The persons will tell you what they had observed or what their experiences were. Right? So that's an interview. That's another method, interview. A questionnaire. Now, the questionnaires, it could be on paper, it could be online, you could use nowadays the popular methods of making questionnaires would be using Google Forms or Microsoft Forms, right? Those are popular. You probably never meet or speak with the interviewees, right? They receive, whether by email or some other method, they receive your questions, they fill it out, and they send it back, right? Maybe if you know the persons and you speak with them before, then a lot more of them will fill out the questionnaire. But if they are strangers, maybe you have to give them a little incentive to fill it out, because many of them, maybe the vast majority of them will not be answered. So if you give them a little money or a little subscription to some magazine that they would be interested in or something like that, right? Or maybe to tell them that you're going to put the link to their Instagram or their YouTube on your website, a big website, that will incentivize them to fill out the questionnaires. So, methods of collecting data. So you observe, or you interview, or you put out questionnaires, right? The last one is the schedules. Here, you, the interviewer, actually have the question, and when you ask those who you are interviewing and they answer, you yourself fill out the question, right? And then probably You show them what you filled out and ask them if they agree to it and if they think that it reflects what they actually were saying, reflect their opinions and so on and so forth. Alright? So those are the four main methods of collecting data. Now, the type of studies, it may be a case study where you study the students in one particular school or the employees in one particular company, and you go there every day for a whole week or 2 weeks or whatever the case is. It could be a whole month, and you study what takes place in that particular school or in that particular workplace. That's a case study, right? Now, when you see the word census, it means you study the entire population. Everybody. It could be all the employees in the company. You give a questionnaire to all of them or to each of them, or you could study all students in a school. Now, every 10 years or so, government conduct a census where they send workers all over the place to study all the persons living in the population. At least they try. So that's a census. So you're looking at the entire population. Now, of course, census is very, very expensive. It takes a lot of resources, a lot of money to carry out a census, right? Now, in most cases, you don't have all of that resources to carry out a census, all of that time and money to spend on paying workers and so on and so forth. So you do a sample. Whenever there's a general election coming up, you have these people carrying out polls. And they try to predict which party is going to win. Or you have other cases where they want the opinions of persons in a population, in an island, in a country, and so on. Now, you may have a population, for example, in Jamaica, about 3 million. But you might have a company that conducts surveys, specializes in conducting surveys. They certainly don't have the money to go and conduct a survey among 3 million persons, right? So what they do, they conduct a survey among 3,000 persons, and then from their feedback, they make some inference. If 75% of these 3,000 persons says this party is going to win the next election, they infer and say this party is going to win the next election based on the sample that we did. So you're looking at a sample where they study part of a population. The observational study would come from observation, and you have a method of studying that is called an experiment as well. It could be in a science lab, it could be some social experiment, it could be scientific, as I said, in the science lab. You the observer, you carry out the experiment and you fix the variables and so on and so forth. You have scientists doing experiments on rats using some new type of medication, studying the effects on rats. Or it could be some social scientist doing some experiments on motivation. It could be on persons, it could be on animals, whatever the case is, alright? But this is an experiment being done. It could be on the chemical reactions those type of things, right? So that's a method that you can use to collect data as well, other than the four main methods that are listed up here. Now, you look at the uses and abuses of statistics. I saw a very good website that contains information on the uses and abuses of statistics. Let's look at it. All right. Here, it's from the Department of Mathematics and Computer Science, Emory Oxford College, and you have the website up here. Now, uses and abuses of statistics. Statistics is used to organize, summarize, present, and or analyze data, often with the intent of approximating the behavior of a population through examination of samples taken from the population, from that population. Testing hypothesis. Hypothesis testing is where you make an assumption, right? As I said before, we're going to deal with that later on. You determine relationship between variables. So variable would be, for example, the heights of persons or the weights of bags of chips being sold, right? They can change, they can vary between one thing and the other. One person have a different height from another. So you say vary, you call it a variable. So relationships between variables and making predictions from existing data. So you make predictions, you infer what's going to happen based on what you have known. Now, that's a good use of statistics. Let's continue. However, statistics can be abused too. Abuse of statistics. So scammers and tricksters and liars and those trying to deceive, to tell lie, can actually abuse statistics. You see it as abuse, but they see it as using statistics. The deceivers don't see it as abuse at all. It's something that benefits them. But anyway, statistics can be abused too. The following lists some ways in which this frequently happens. Quoting statistics based on non-representative samples, right? You might go in a garrison that's strongly aligned to one particular political party. You do your interview and 99% of them say that they will vote for this particular political party. Well, that would be an extreme example, right? So you predict that this party is going to win, and you hope that the voters will just give up and say, all right, the poll says that this party is going to win, so I might as well vote for them. Or if they're strongly committed to their party, they say that my party is going to lose, so I won't bother to waste time going out to vote. Well, some people might think like that, and they hope that that's what's going to happen. Choosing the average value of a sample which most lends itself to your position, when a different average would be more appropriate. So that's deceptive, right? Speaking of changes in a variable in terms of actual values or percentage, to either inflate or deflate their importance psychologically. How happy would you be if your network increases by $10 million? What if that only represented a 0.3% increase? Right? So, psychologically trying to manipulate persons. It could be someone who's trying to manipulate those who hold shares in a company, and they say, put out some false news that this company is likely to lose value because there is a scandal brewing among management. and then they hope that all of you out there will sell your shares so that the value drops. And then when the value drops low, they will buy their shares. They will buy shares in the company and hope that it will rise again soon. That would be somewhat fraudulent. Using detached statistics like 1/3 fewer carbs. Fewer than what? They're trying to sell you some weight loss product, and they don't tell you everything, right? They just tell you this contains 1/3 fewer carbohydrates, so you should buy it, trying to sound good. But if you think about what they're saying, you might question them, then they get angry, curse you off, and move on to their next potential victim. All right, implying causal connection between variables without well-designed experiments to back it up. That is, doctors say that by taking lipotrim twice a day may reduce your weight by up to 30 pounds in the first 2 weeks. Well, they try to make it sound as if it's because doctors say it, that's why it will happen. And they trying to convince you to buy lipotrim because doctors say that this will happen. If you take it, if you buy it and use it, it may reduce your weight by up to 30 pounds in the first 2 weeks. All right, now here the term may reduce. You will see this on various supplements. They cannot say will reduce because saying that is illegal. If they could get away with it, they could convince you by saying it will reduce your weight. But they have to say that it may reduce. Because once you say it will reduce, then you can be taken to court and you will be asked to present how it will reduce your weight. So you'd have to say may reduce. Now, in this case, the deceiver trying to sell their product is using the statement that doctors say. They don't say which doctors, They can't point out which doctors. They just say doctors say. All right, formatting graph to mislead the eye. Right? Designing questions to be used on a survey that will bias the results. Trying to fix up the way the question is set up. Trying to make you answer in a particular way. All right. No, so those are some of the uses and abuses of statistics. Now, the primary data and secondary data. These are two types of data. So you can have, in terms of how they are collected, they may be primary data or secondary data. Primary data is what you go out there and collect. Well, not necessarily go out in a field. It could be you're in a lab or some way, or it could be that you are in your office or home and you make telephone calls. What you are not necessarily telephone calls, but you observe what's happening out there. You could be doing experiments on plants. You could be observing the behavior of students in a school, and so on and so forth. That's primary data. It's first-hand news. It's like first-hand news. You are the one who went out there and you saw and heard what happened. That's primary data. Now, secondary data is what somebody else did and published. So that's second-hand news. Right? It could be from websites, the newspapers, magazines, some published document that somebody else did already and published, wrote and published. So that's secondary data to you. You are collecting data from what other persons have gathered already. So that's secondary data, right? Now, data can also be the type of data. It can be categorized as qualitative or quantitative data. No, qualitative data. Quality. It's opinions and observations. For example, the color of clothes, right? Or it could be the models of cars, or the shades of gray of certain tiles. Those are qualitative data. And then you have quantitative data. Those are numerical data. It comes from measurements. It could be the weights of various patients coming in to a doctor's office or health center. It could be the weights or the size, the volume of various containers of paints, right? Once it's something that you can measure. It could be the speeds of motor vehicles passing at a certain point on a road. It could be the temperature of, for example, the surface of a floor on different times of days. So those are quantitative data, quantity, numbers. You can put numbers to them. Now, quantitative data, there are two types. You have the discrete and the continuous data. The discrete data is where you can count. Usually, you count 1, 2, 3, 4, 5, but you don't have any values between 2 and 3. Example, number of chairs in a room. The number of chairs. You can have 2 chairs or 3 chairs, but you can't have 2.5 chairs. It could be the number of participants in a meeting. You can have 15 persons in the meeting or 16 persons in the meeting, but you cannot have 15.3 persons or 15.5 persons in the meeting. That's discrete. You know, when you're arguing with somebody about a certain situation and they say you should use your discretion. Your discretion means you're able to distinguish between one situation and another. Right? The difference. So, discrete data, clear difference between one and the other. The thing is, discrete data, it can contain fractions. For example, shoe size. You can have a size 10, a size 10 and a half, a size 11 pair of shoes. Let me try and draw my shoes, or my shoe here. And you have the laces of the shoes. Okay. Alright, so in this case, you have a size 10 shoe and a size 10 and a half, then size 11. But you don't have anything between size 10 and 10 and a half. That's still discrete data, right? Because you do have size 11 and a half, then size 12, but you don't have any shoe size between these. So you have a clear difference between one and the other. Clear distinction between one and the other. Then you have continuous data. With the continuous data, you're talking about a case where you can always take a measurement between 2 given measurements. Now, in this case, it could be the heights of plants, right? Trying to write heights. H-E-I-G-H-T-S of plants or of seedlings. So the seedling would be a small plant. You start to grow. Some of them, they grow in trays, right? And after a week or 2 or 3 weeks, they have a certain height, right? Now, the thing is, if you have the height of a plant and you say the height is 20 cm, now you can have a ruler measuring 20 cm and you measure it very quickly. Somebody else can measure, take some more time to measure it, and they find that is actually 20.2 centimeters. Now, using a more accurate method, you can use laser and you measure it and say, it is 20.25 centimeters. Then you take an even more accurate measurement and you measure 20.251 centimeters. But the argument here continues is that no matter what 2 measurements you take, you can always have 2 other measurements between. So 20.5, 20.6. Between 20.5 and 20.6, you can have 20.55 and 20.6. But you can also have 20.553 and 20.6. 2 measurements between 20.55 and 20.6. You can still have another measurement between them. 20.53. You can still have another measurement between 20.553 and 20.6. You can have 20.5537 and 20.6. That's measurement between 20.553 and 20.6. That's 20.5537 and 20.6. But you can still have a measurement between 20.5537 and 20.6. It could be 20.55376 and 20.6. Now, you can go on and on with this. Remember, with discrete data, is either you have 10 people in the meeting or 11 people in the meeting, but you can have any number between 10 and 11. But with continuous data, you could go on continuously finding measurements between one number and the other. Right? There is no break, there is no cutoff point, it's continuous. So you call that continuous data. It could be in centimeters or grams or kilometers per hour, or it could be force in newtons, weight in kilogram or pound, whatever it is. Right? That's continuous data. Now, types of statistics. You have the descriptive statistics and the infer statistics. Now, I got this definition. I copied it from page 5 of the 8th edition of Statistics for Business and Economics, written by Newbold, Carson, and Thorne. Right? Very big, thick book with statistics specifically for business. So it's a good book for anyone who want to go in depth in studying business statistics. Now, here, descriptive statistics focus on graphical and numerical procedures that are used to summarize and process data. So you're describing the situation You're describing the numbers using statistics. That's descriptive statistics. You're describing what you found, all right? Now, inferential statistics focus on using the data to make prediction, to forecast and estimate, to make better decisions. So, you're saying that based on this data, you expect that, or based on the data and the population growth, you expect that the population will reach, or it could be bacterial population growth or viral population growth. Based on what you saw, you estimate that the population of viruses will reach 75 million in the next 12 hours. Our human population, the population of the country, will reach 5 million in the next 15 years. Or it could be sales forecast based on what's happening. If we continue to advertise at this rate, our sales will surpass $3 million by the next 6 months. Or it could be from your studying 3,000 persons from a population of 3 million. You're studying 3,000 persons. You're inferring that the whole population is also thinking this way. A particular political party, based on your sample of 3,000, a particular political party is doing better in the polls and is set to win in this, based on this particular principle, right? You're predicting based on the 3,000 that you sample that this party will win the next election. Now remember, it's just 3,000 you took as sample, but you're inferring that the behavior and the thinking and the voting practices of these, the voting opinions of these 3,000 persons is the same as the entire population of 3 million. So you're making an inference, right? So you have the descriptive statistics, where you're just describing what you found, and then the inferential statistics, where you're predicting based on what you found, this will happen in the future, right? Or this is how everybody is thinking based on the sample that you took. All right, so those are just some terms that we want to get out of the way and to take a look at. All right, so I suggest you keep reading about these terms, look at additional examples, and so on and so forth. So we'll continue looking at statistics in the next video. So I'll see you.